Hello. Welcome to 5th International Symposium on Multidisciplinary Studies and Innovative Technologies. Due to COVID-19, we are organizing the symposium virtually. I hope this epidemic will end as soon as possible. Let's start session. First paper belongs to Filiz and Sanable. Is online? No. Second paper, Guang Zhang. Third paper, Kezban Alpan. Are you ready?
Good morning. I am online.
Good morning. Okay. If you are ready, you can start your presentation, please.
That's okay. I'm ready. Hi. Good morning.
Hi.
I will share my screen now.
Yes.
Sorry. Can you see my screen, sir?
Yes.
Okay. So good morning again. My name is Kezban Alpan. I'm a lecturer at Nearest University, Faculty of
Please, you have 10 minutes.
Okay, thank you. Okay.
Thank you.
I'm a lecturer at Nearest University, North Cyprus, and I'm a PhD candidate at Middlesex University in Department of Computer Science. And today I want to deliver my research, which is about performance evaluation of classification algorithms for early detection of behavior determinant-based cervical cancer. So HPV is a sexually transmitted infection, and it is very common. This virus is shown as main cause of cervical cancers, and which is the fourth common woman cancer worldwide. During 2020, more than 340,000 women died because of this cancer type. Cervical cancer that started to decrease since scientists revealed that this cancer is preventable. But it's true, what's showing in the graphic is true. We can still do better, we can still work much better to make this cancer type more preventable, and no woman should die because of cervical cancer. There are 4 steps of cervical cancer, and these all steps are preventable. There's a vaccination opportunity for 11 and 12 years old. For ages between 21 and 65, there is a screening opportunity to find out the infection and treat it. And if the infection turns into precancers, there is still chance and opportunity to turn it back to normal. But once it's a cervical cancer, it's spreading because it's in abdomen, it's close to abdomen. There is a very high percentage of metastasis, and chemotherapy will be the only solution. This study aims to analyze performance evaluation of different classification algorithms for early detection of behavior determinant based cervical cancer data set. As previous researchers revealed that behavior of the patient can be used as a predictor with its determinants for early detection of this cancer type. And in this research, I've used VECA tool for experiments. I want to talk about my data set. 72 women entered to cervical screening for this data set, and it includes 19 attributes. 18 of these attributes are about behaviors of patients, women, and it's got obtained by a questionnaire. And last one, 19 attribute is a class and is categorized as woman has cervical cancer or woman has no cervical cancer. And this data set obtained from UCI data repository. These classification algorithms were used in this study. So it's BiasNet, naive Bayes, logistic regression, k-nearest neighbor, J48 decision tree, random tree, random forest, and support vector machine. All for this study for application of experiments, 10-fold cross-validation technique is used to split training set and testing data set. When we look at the results of experiments, we can see that support vector machine showed the highest accuracy performance with 91.67%. And naive Bayes is the next successful algorithm with 90.27%. The difference is just 1%, but if we can consider that there are millions of women who are suffering with cervical cancer, even that difference gonna make, that 1% gonna make lots of difference. Logistic regression, k-nearest network, and random tree show same performance with 88.88%. And BiasNet and random forest have same accuracy with 78.50%. And J48 has the lowest accuracy with 84.72%, but all algorithms can be considered as successful. As I said, because millions of patients, women, are suffering from this cancer type, even 1% is a very big difference. As a result of this study, all techniques work over 84% accuracy, while support vector machine showed the highest and best performance with 91.67%. So we can say that support vector machine is an effective classification technique to identify behavior determinant-based cervical cancer and has very high performance to help medical workers for early diagnosis of this cancer type based on these attributes. So thank you for listening me. These are all that I want to say. And if you have any question, I will try to answer.
Thank you for your presentation. Dear participants, do you have any question about the paper? Okay, no question. I wish you success. Thank you again.
Thank you.
Ms. Kezban Alpan.
Thank you, sir. Thank you. Have a nice day.
Okay, I'm sorry, I'm Filiz Alşanabli, and
okay,
I
if
was
you are
having a
ready, you
problem.
can start
Yes,
your
yes.
presentation.
Yes,
if you are ready,
I
you
was
can
the
start.
first, I think, but I'm sorry,
Okay.
I'm very sorry. I involved
Okay.
a little bit late. Okay, let me share.
Not a problem. Okay.
Okay.
If you are ready, you can start your presentation.
Okay, I'm ready.
You have 10 minutes, please, at
Okay,
most.
okay. Thank you very much. Let me open the videos also. Okay. This one, share. Okay. Yes, it is going to be talk about. Yes, I'm going to talk about failure investigation of prematurely fractured stainless steel bone fixation implant. We have prepared and with real data here. First of all, let me define why we need such an implants, because bones can fracture. When they fracture, they are going to be healed themselves. But some cases interventions are going to be required. So for such an interventions are going to be in terms of fixation plates and screws and long time of consolidation by traditional methods without implant. They are going to be provoke, if there is no implant, atrophy of the cartilages. So Orthopedic fixation implants, they are going to be used to accelerate bone consolidation after the fracture is going to be occur. Why we are using them to stabilize the osteotomies and to perform arthrodesis. They are the sectioning and the realignment of the bones and stiffening of the joints by fusion of the bones. There is some type of, for different purposes, some type of fixation devices, just to give an idea. There's a list for them. And the material for this application, for such an application, internal fixation, we're using different materials. Just I have listed according to their importance, because when we are using some material and in engineering purposes, of course, we are looking at the low cost, and if they are going to be do the same job. So austenitic steel, iron, most of the time is going to be chosen as a material for such an application due to their low cost, easy fabrication, and we're using austenitic iron because of their corrosion resistance and because they are non-magnetic materials. And of course, titanium alloys and cobalt alloys, specifically titanium alloys, they have good ductility, good machining, excellent wear and corrosion resistance, but they are very high cost. And another advantages of them, they are very light compared to the stainless steel. Some bioresorbable biological materials, they are going to be absorbed through the body. So the pins and the screws are going to be during the healing process, could be done by bioresorbable materials, but difficult to find suitable material for the application. So only applications are the metals up to date. So why metallic implant? Because they have suitable mechanical properties like high elastic modulus, like useful and high yield strength and enough ductility. You can easily give a shape and sufficient fatigue strength. They are good in corrosion resistance. You can find biocompatible metals and you can manufacture them easily and they are low cost. The restriction of when we are choosing metallic implants, they should be non-magnetic properties, because when we are using in the application of, let's say, MR application, if it is magnetic, we cannot use such an implant. So the material here chosen, austenitic FCC structure, is going to be non-magnetic type, should be chosen. Failure mechanism of internal fixation plates. There is they can be failed, those fixation implants, due to failure of the bones to heal and bone resorption, breakage of bone, loosening of the implants, and bending of implants. And generally, we are classifying those of all of these things in the two categories. Either mechanism is going to be biochemical failure or biomechanical failure. It is a fracture, wear, or losing. And the fracture modes are going to failure modes of orthopedic implants. And where we are seeing is going to be summarized here. And if there's an overload, the bone which implant is located, bone itself, it could be a fracture, and implant and screw holes could be fracture. The most common type of failure modes is the fatigue, and bones and also implants are going to be fractured. Corrosion is because of the new technologies and suitable materials. Corrosion is going to be the less failure modes we are going to be see, and loosening of the screws, and because of the motion and so on, is going to be the modes of the failure. The most important one is the fatigue, and because of our case study, we have to investigate the fatigue mode. The cyclic load is the main reason for the fatigue. Even at lower forces, loads we are going to apply. If we are applying a long term of cyclic loads, when I say cyclic loads, in the same frequency of walking or running or whatever it is, in the case of implant materials, even the load is very low, but if it takes long time, this cyclic load, the fracture is going to be occur. If the magnitude of the load is going to be larger, fracture is going to be occur very soon. So cyclic load, the intensity and the magnitude of the cyclic loads are important application criteria for orthopedic fixation implants. In the research, many research, it is shown that 10 to the power 7 cycle with 150 kilonewton will be sufficient for the fracture of the astotonic type of the stainless steel. And it corresponds to this much of cycle, 7,000 something cycle, approximately 8,000 cycle. And if the patient walks 3 hours per day, and healing process with orthopedic implants is going to allow this much of cycle, 6 months, and the average number of steps during the days are going to be 2,250 cycles per leg. And if the person is exiting 3 hours per day of walking with this much of course, walking intensity, this much of load, it is going to be healed. The bones are going to be healed. Now we are going to do some failure analysis because we have investigated some cases for the implant fail in use. The process of collecting and analyzing data determine the cause of failure. We call it failure analysis. It can save money and lives and resources. The process relies collecting of the fail component and making examination of those components. In the present case, failure analysis of the prematurely failed internal fixation plate, which is a femur shaft fracture occur. This is our patient's fracture bones. Before 7 months, this implant is going to be installed in his body. But after 7 months of the surgery, again, this implant plus the bone, maybe it didn't heal, or maybe it is rebroken again. It was broken, and we investigate why it is broken in this case. And it was made up of, the implant, it was made up of stainless 316L stainless steel. It is failed. So failure analysis take place in 3 parts, which is visual examination. We do hardness test to estimate the mechanical properties, and we are going to do metallographical examination. In visual inspection, we investigate, we find the sizes of implant is clean, removed from the body, and it is clean, and its fracture is going to be occur in the longitudinal side. And in the visual inspection, the surface, I mean this surface of the implant was smooth. We couldn't investigate in the screws and in the plate. We didn't investigate any corrosion artifacts. There is a few scratches, and it is going to be shown that maybe they are not going to be handled, those scratches, because of they didn't handle before, after, and during operation. The according of the ASTM standard, it didn't handle properly, but not because of the manufacturing, those scratches. Okay, the visual inspection is going to be carried out. This is the most important part of the investigation, failure analysis. We are fracture surface, matting surfaces, we are investigating. The first thing we investigate that there is a plastic lips, all the corners, broken corner, plastic lips. It's mean that it is deformed plastically. So the material is not so much brittle, it is a ductile, it is going to show us. There's a river pattern, there's a cleavage system, it is going to be shown. Cleavage is similar to fatigue, but it is for brittle materials. And it is going to be, it is satisfying with the materials properties. There's a beach marks. It is going to be barely identified, but when we look from the very close way, we are seeing the beach marks, like a sand mark. There is a marks here, and it's mean that fractures start from this point. Fracture is starting this point, and the beach marks and the river patterns are going to be shown that it's a fatigue. It is a sign for fatigue deformation. Hardness test is going to be done, and just to see that if it is our material is, as they say, it is going to be 316L stainless steel. We have several tests we have done, and the average of the hardness value for the material was corresponds to 38 Rockwell hardness, and it is going to be converted to Brinell hardness, and it is going to give us 348, which is give us the ultimate tensile strength, Brinell hardness. And the minimum mechanical properties for 316L stainless steel plate, according to ASTM, is this one. It's mean that our plate was enough strong because its tensile strength is 1,200 megapascals. So both tensile strength and Rockwell C hardness values match with the specification. Metallurgical investigation is carried out using optical microscopy. In optical microscopy, the surface of the sample is etched with some acidic solution to polish the surface, and we are able to look the inside of the material as much as possible. And we are going to see some twin boundaries and the shear bands. Those are the shear bands produced during the cyclic load. Those are the evidence of the cyclic load. There's a martensite nucleation during the shear bands. Normally, austenitic stainless steel doesn't have martensite structure. Martensite structure is formed during production of this material, and it makes the material a little bit brittle, and it is explaining the cleavage things. So the conclusion is patient didn't follow the medical recommendation, and the premature failure of the implant is occur. And the fatigue was the main failure mechanism, which we are going to observe. And the failure are mainly provoked by cyclic load. The patient used his legs more than, and maybe he didn't use in normal walking. He played maybe football again or something like this. And microstructure present slip bands and deformation induce martensite. Martensite is going to give us an idea for the cleavage and another mechanism for failure. The implant analyzes present very poor surface finishing, and the fatigue resistance of 316L implant could improve for better surface finishing because they are the fracture initiations. The hardness test and the tensile test estimated from it show that material did not fail because of the pure properties or load exceeding its ultimate tensile strength, but it is because of the fatigue failure. Okay, and intensity of the cyclic. Okay, and microscopic examination also noted that the sign of fatigue failure is going to be noted. Thank you for listening.
Thank you for your presentation.
If
Dear
any question.
participant, do you have any question about the paper?
Okay.
Okay, no question. I wish you success in your career.
Thank you. Thank you.
Okay,
Let me
thank you
move.
again. Next paper belongs to dear Guyangzang is online. Guyangzang is online. Okay. Martin Kaloev, dear Martin Kaloev, are you ready to present?
Yes, I'm here. I'm here.
Okay. You can start if you want.
Okay, so let's start.
Okay. You have 10 minutes, please.
Yeah, my presentation is on the screen. Yes, yes, I think is it.
Yes.
Okay, so my presentation is about experiments focused on exploration in deep reinforcement learning. I'm artificial neural networks architect, and this is my presentation. So what we're going to talk about it is reinforcement learning groups. Reinforcement learning groups are a specific type of machine learning that we use in everyday life, like digital assistants, self-driving machines, cars, Google, YouTube algorithm. They use reinforcement learning groups, but we need to understand this technology always a little bit more. So our experiments is based on this. For example, can we accelerate the learning process? Can the machine learn from each other? What happens if we put some restriction on the exploration of the machine? This kind of stuff. So what is reinforcement learning? Whoops. Environment, for example, if we're going to talk about self-driving cars, this is the road. If the car do happen to move without failure, the reinforcement learning group is successful and the car try to represent. If we're talking about Google or YouTube algorithms, if they succeed to present us with something that we like, the more information of this type will be reintroduced to us. This is the reinforcement learning groups. It's fairly simple, easy to understand the concept. So what is exploration and exploitation? So since this machine don't have static information to learn, they try to have two life cycle, one cycle of exploration that they just try new stuff, and if the stuff is good and succeed, they try to replicate it, and the exploitation is the cycle of repeating the successes and avoiding the failures. What is the good and bad exploration? Good exploration is when the machine do understand what type of actions are good. They have very good understanding, and they can assign proper marks to the action. So you can see good exploration next to the real value of the action. And the bad exploration is when the machine explore a very small fraction of the whole environment and assign an unnecessary high value to an action. So you can see the value is, this is the Q assignment. It's way off of the real value of the action. This is good in the back exploration. So what are our experiments? We did use the famous experiment of the Barto and the pull card, or the card that try to keep the balance. You can check it, it's called card pull experiment of the Barto. It's in the reference. And we do have 4 types of experiments. First type is the control group. Control group is a group where the machine learning algorithm or the small AI have good exploration and good exploitation, and their balance. This is the control group. The next is we give the machine very small amount of exploration loop, and after this loop is ended, we try to see how good the machine can balance. The third is restrictions. So we say to the machine that they can exploit the environment or how to balance the card, but if they go too close to a failure, we assign a stop of the exploration and begin to try to regain the balance. And the fourth and the final experiment is what if we make the machine only watch how way better, more advanced algorithm balance this card, and can the machine learn from more advanced algorithms from only what without their own exploration, what will happen, of course. So this is about our experiment. But after the machine is trained well, we change the architecture, but I'll talk about it a little more in the next slide. First, let's talk about more about exploration. So this is the card you can see, and when the pool begin to drop on the one side in pretty high degrees, we said no, go in the other side and try to balance. And this is our restrictions. So what do we mean when we change the algorithms? You must know about the machine learning algorithms in reinforcement learning loops. They have a lot of architecture. What we are using is A to C architecture. That meaning two neural networks, actor, critic. Let's talk about it a little bit. So we can see the actor is the one neural network and the critic is the other neural networks. The critic judge how good is the action, and the actor tries to replicate the action, but the critics tell them, is it good or not? This is the A to C algorithm. And after we finish the training, we change the architecture from AC2 to DKN to AC, meaning that we do change the actor neural networks with different types of neural networks that doesn't return logarithmic values, but turn linear values. Logarithmic values meaning from 0 to 1, and linear meaning to from minus infinity to plus infinity, because we do want to know what how the machine perceive action, what values do a machine give to a certain action. This is why we do change the architecture, of course. This is some extra information. I must say that the whole code is put in the reference in the paper, and if you want to see the more details, the whole thing, you can download it from my GitHub and try it for yourself. So this is some extra information you need to see if you want to replicate the experiment. First, what is the architecture is 4, 24, 12, 2. Activation function is Revoluki. Loss function is for the last layer, of course. Loss function is mean square error function with linear, and after the change turns from the softmax into a linear, of course, meaning from AC2 turns to DKN / 2C is the turning from softmax into actor networks to linear. It's self-explanatory. You can check it for yourself. This is explanation why we need to introduce this change. Another thing is, another thing is, this change going to ruin the memories in the network, the neural networks. If the neural networks are set to read and write, they will be ruined, but for the observation experiment after the machine's already training. We did send them to read only because we don't want to ruin the memories in the already neural networks. But you must keep this in mind that for the second part of the experiment, they're read only, yes. And the final thing is, because in the reinforcement learning, sometimes you do have not two neural networks, but maybe four, because you want to keep one neural networks in prelude mode only for training and another only from the responding environment. And since the reinforcement loop is pretty small, we're going to stick in the simplistic way with only two and not four, because if you have four and we do bring the such a big pool of information, we're going to make the neural networks to overfit because they're pretty small. That's yeah, it's small details about the architecture, but you must keep this in mind if you want to replicate the experiment. The results is what the results in the paper are the big raw data, what we find, and what we do find is the very best thing is when the machine is learning from already experienced machine from watching how it works, but only if we give enough loops, enough times to watch how the experienced machine working. And if we give the learning machine pretty small amount of learning information, they will do really, really bad, even worse than the control group, of course. And the second very interesting thing that we find is when you give a restriction to the machine, we did not expect this, and this is very interesting, is that the machine, they can develop their own strategy that we do not expect this strategy to even exist. So you can say that artificial intelligence did go rogue like did their own thing. Very interesting, very exciting thing. And this is the interesting discussion we want to say. And that is after some looping where the car tried to balance, they decide for the last thing when the loop is already going to fall, they did not try to balance it. No, they did try to give extra falling. I mean, they did try to cheat some extra seconds by moving really, really fast in the falling direction, not trying to balance the car, but to extend the falling, if you may imagine it. I mean, meaning that artificial intelligence is trying to cheat a few extra seconds. That's exciting because it's something new, it's something strategy that it's not expected to behave this way, but it does. And why does it do these things? Because when you remember about the restrictions of the experiment, we tell them, if you're going to fail, you must just go in the opposite. And they're learning this behavior so much that they decided, whenever I try to fail, I will not try to balance it. I'll just try to go really, really fast in the firing direction. And this is why they're trying to cheat, because they're learning. They don't understand why this exists in this shape or form, but they do try to replicate it, and that's interesting. Conclusion, we talked already about the conclusion. This is what we mean from turning from A to C to DKN/ to C, meaning you can see. So, okay, I'll I'll proceed. You can see from turning from 0 to 1, this is the logarithmic type, and when it's turned to decay, it's from -60 to 100. This gives us the way clear way to see the overestimation. This is why we changed the architecture. This is the cheating. You can see the overestimation to moving left is 250, and the overestimation of turning right is -50. And that's the interesting thing. The behavior, they learn so much that they need to overcompensate it, that they give these negative values. The good versus the bad teacher, this is what will happen well balanced when the machine is learning from well-adjusted artificial intelligence. They can balance in the good way, and they don't give big overestimation. The overestimation is always good into 1 or 1.5 good estimation, but the estimation is -50, the bad one that give worse results from the control group. And this is my presentation. Thank you for your attention. If you have extra question or want to talk about it, this is my email. You can write it. I'll be really happy to talk about this. Also, if you have some question now, so you can ask me.
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your career.
Thank you, Daniel.
The next paper belongs to Nadjette Ben Hamida. Are you ready to present?
Yes, I'm here.
Okay, you can start your presentation, please. You have 10 minutes.
Okay,
It's important, please.
thank you. I don't know how. So this work is about the performance enhancement of cache consistency mechanism in mobile computing environment. I will present the following points: introduction, proposed approach, performance metrics, performance results, and conclusion and future work. In mobile computing, nodes collaborate and share data to organize themselves according to collaborative architecture. This improves the system performance because of data sharing and nodes coordination. The collaborative architecture increases the network congestion, the node overload, and the latency. However, inefficient management of the cache memories resolves these problems as following: reducing the end-user latency, decreasing the end-user device overload, minimizing the bandwidth consumption and the network congestion, improving the information availability, and decreasing the end-user device energy consumption. An efficient management concerns mainly the replacement strategy and the consistency mechanism of the cache data. So in this work, we are interested in improving the performance of the data consistency mechanism in the cache of wireless mobile computing network by firstly assessing the relationship between the consistency mechanism's performance and the replacement strategy and determine whether they are correlated or not. Secondly, by using the IoT data lifetime and variable TTL concept in the basic TTL consistency mechanism. So for this reason, we integrate the consistency mechanism algorithm and the replacement strategy algorithm in the same process. And in order to evaluate the performance of our solution, we use the following metrics: the hit rate, which represents the percentage of coherent requests retrieved directly from the cache, and the byte hit rate, which represents the percentage of coherent byte obtained directly from the cache. We present in the following an intra-mechanism comparison to assess the performance of every consistency mechanism using different replacement strategies. So for the fixed TTL mechanism performance, figure 3 donc show that the fixed TTL hit rate varies according to the replacement strategy, and so we can say that the fixed TTL hit rate depends on the replacement strategy. Also, the LRFE strategy provides better results than the LFE strategy. So we can say that the relative frequency improves the LFE hit rate, and finally, the LRE strategy provides the best results, followed by the LFE, respectively. So we can say that the relative frequency improves the fixed TTL hit rate. Also, for the fixed TTL byte hit rate, it is shown that the fixed TTL byte hit rate changes according to the replacement strategy, and the LFE strategy provides results close to the LFE results, while the LFE performance are the worst. For the variable TTL mechanism performance, it is clear that the variable TTL hit rate depends and changes according to the replacement strategy, and the relative frequency improves the LFE performance. And finally, for the variable TTL byte hit rate, it is shown that the byte hit rate depends and changes according to the replacement strategy, and also the relative frequency improves the LFE byte hit rate. And finally, we can say that in wireless mobile computing, the consistency mechanism performance strongly depends on the implemented replacement strategy. The relative frequency and the variable TTL improves the consistency mechanism performance. The recency-based replacement strategies provides the best performance than the frequency-based strategies, and the relative frequency improves the performance of the frequency-based strategies in terms of data availability and user latency. And finally, the variable TTL mechanism provides results close to the fixed TTL mechanism in terms of hit rate and improves the byte hit rate. Thank you. But for the future work, we are interested in proving the correlation between consistency mechanisms and replacement strategies using an alternate mechanisms and more criteria and factor and different context. Thank you. Thank you. So
Okay, sorry. Dear Najetmi Benhamida, you finished your presentation?
Yes,
Okay, okay.
thank you.
Thank you. I wish you success in your career.
Thank you.
Sorry, I was a problem before.
I understand. C'est pas un problème.
Next paper belong to Negoslav Sabev. Are you ready to present?
Hello. Due to some technical issues here, I asked my colleague and a co-author Mirena Ekmekci to present the paper on my behalf.
Okay, okay, no
Hope she's
problem.
here.
Okay.
Yes, I'm here.
So
Okay.
thank you, Mirena. You agreed to present it.
Thank you, no problem. And thank you for the cooperation in general for the research. So am I ready to present?
Miss Mirena Todorova, you have 10 minutes, please. Okay.
Yes.
Okay.
Sharing the screen. Are you seeing the screen?
Not yet. Okay.
Now?
Okay. Yes, I see your presentation.
Okay, thank you. So the presentation is about physical disabilities and researching accessibility in museums in the new COVID reality. This includes physical and online accessibility for people with disabilities and especially people who are blind or visually impaired. We are a team of scientists from Bulgarian Academy of Science. Negoslav is one of them. He already presented himself, and in the first slide, we are showing you the beauty of Bulgaria, including natural sites and cultural sites. We are now focusing on this project more on the historical and cultural side, but you can actually see that Bulgaria is quite rich in. You're seeing the slides changing. Yes, sorry for the question. Just to be sure that you're seeing the changing of the sites. Okay, so Bulgaria has more than 10,000 sites of national importance. 7 of them are in UNESCO about real cultural values, and 11 Bulgarian sites are in the intangible and intangible world cultural heritage of UNESCO. And Bulgaria is quite popular destination for natural and cultural exploring of tourists. This is also one of the main touristical aims in the strategy for tourism in Bulgaria 2014 and 2013. Cultural tourism ranks 3rd among Bulgarian citizens, and this changes in the seasons, but basically, in short, it is very important for Bulgaria tourism, and not just local tourists, but also tourists from abroad. And in order to improve the access of those tourists in Bulgaria, we need to improve our digital and digital presence and physical accessibility of the sites. On this slide, you can see Veliko Trnovo fortress, which is quite hard to access from people with disabilities, but otherwise very beautiful place. Our research insights shows that most of the tourists are getting information from tour guides, operators, travel agencies, and websites. Actually, all the team included in this research is from Veliko Trnovo city, which holds this fortress, Tsarovets fortress. And we are seeing really many tourists, and many of them are foreign, and they really get the information. They come already instructed. So our conclusion is that they get a lot of information in advance for the tourist site they visit. And this includes exploring the sites of the cultural and historical objects and sites, including museums. And the problem we are researching in this paper is ineffective marketing strategy, weaknesses, actually, in total weaknesses of Bulgarian agencies presenting our cultural heritage, and also weaknesses of the sites and museums to present the cultural and historical heritage of Bulgaria. There is not enough information, and in a modern and contextual interpretation way. There is not so good infrastructure involving people with disabilities or elder people. There is much more to go for presenting Bulgarian tourism's richness and sites in a better way. Previous investigations of the team were made in 2016 from the Institute of Bulgarian Informatics and Mathematics team and volunteers. It was mostly physical research on that time, and it concluded that most of the sites didn't provide special facilities for people with disabilities, and only 50% of the public websites were really accessible for especially people with visual disabilities and impairment. In 2012, we continued and expanded the research, focusing more on the digital part than the physical part, but we also checked with the team, and especially Neguslav and Živko Tomov in the team checked with real testing, not just program software testing, the accessibility of the sites of museums and governmental institutions. 12 from the, if we compare with 2016, in 3 years, only 12 of the research sites have improved some parts of their sites to be more accessible for people with visual impairment. And focusing on the museums, we focused and researched 55 museums. This is one of them. This is actually the good example among them. It's the Museum of Municipal History Museum in Tsarevo. It is very modernized, very well made in a physical and digital way to be accessible for blind people and people with disabilities. There is a access, there is a ramp for people to visit. The floor is flat. There is digital technologies and displays. And going on the next example, this is an application project by Bulgarian and Hungarian Academy of Sciences. Both academies teams have developed this application, Bookhand. You can see the screens of this application. It shows cultural and historical heritage objects, and it's especially made to be also accessible and easy to use from people with visual disabilities, which includes a lot of text, meta tags, out description, pictures of the objects. You can see here access to a huge digital repository of old bells in Bulgaria with historical value, including text, images, and detailed information and sounds. In this application, you can also see more about museums, monuments, churches, and explore easier in the region, especially of Veliko Trnovo and Arbanasi city in Bulgaria. This is another project the team worked on concerning disability. We are showing it because it concerns the sensory accessibility we are explaining in this paper. It's a Bulgarian-Romanian project, the New River, with a lot of history. It's an example how museums and people dealing with cultural historical heritage can show the objects to people who cannot see. This happens through printing 3D models and exhibiting them in special exhibitions or permanent exhibitions. This way, people who cannot see can actually touch the objects without damaging them and perceive the information necessary to understand the cultural heritage. This is more concrete information from the research. 55 museums of 209 have been researched. This is 1/4 of all museums in Bulgaria. We are expanding also currently the research, but this is enough to give some recommendations already for the museums to improve and government. Our research showed that most of the museums don't have ramps and elevators, or if they have, they are not so easily accessible from blind people or visually impaired and disabled and movement disabled people. Most of the time you have to call the staff of the museums in order for them to point you and to guide you to the place where there is a ramp or an elevator. Most of the museums are in old buildings which have stairs and obstacles on the way for people who have hardship to move. There is absence of handrails and missing of the rest of some places there is not enough good pavement to walk on or old pavement with tiles. Another problem are inner thresholds, narrow spaces, especially buildings from Renaissance period like this one on the right, which are mostly wooden and hard to build special facilities for easier accessibility. And currently many of them, people with disabilities can process the information mostly in a digital way. They are harder to access. For open spaces, there are obstacles like not even flooring, different surfaces, slippery terrain, holes and strong slopes, and in most of the places they are not signified in any way for people with disabilities and impaired vision or hearing to see and understand. Majority of the research sites, 76%, are inaccessible, and 23% of the architectural environment was not a problem for their capabilities according to the people who we talked with. So basically, in short, some of the staff museum doesn't even realize that some of the objects and places are not that accessible. Some examples for sensory accommodations, touch, sound, 3D models and exhibitions. It has become a fashion in the latest years to do 3D models and exhibitions, not just to attract the audience, but also to show better accessibility. Those 3D models are actually a chance for people with visual impairment to get the information about the cultural object. If they cannot see, they can touch it. And this creates an idea of how the object is and can be described. Unfortunately, not all the museums make such 3D exhibitions, even though most of them already have such a technology, or not so regular. This was an example from our military museum, and those pictures are showing digital 3D made models, which are also some of them printed in a physical exhibition. This is another example from a ethnographic museum, regional ethnographic museum in Plovdiv. As you can see, this is again very old house, beautiful, but for a blind person, hard to reach and hard to understand without special guidance. You can see on this picture actually a real tour guide with a real group which was explaining about the building and its history and its objects inside. And this real guide can be really helpful for a person with disabilities and visual impairment, but most of the time those guides are not prepared to specifically explain according to the disabilities of the people. For example, most of the time they would not describe you in that much detail that the material of the object or place or the look. They would more focus on the historical part. For example, how it should be described, this house museum, to a blind person. Old historical house with beautiful green yard and painted walls, wooden materials and columns. We have started to work with this museum, our team, and to improve it for digital accessibility. We are currently with the team making audio guides specifically fit for not just normal people, but also people with disabilities, describing more the objects inside without being boring for the normal people. This includes QR technology and a specific web platform made to be accessible by normal and people with visual impairment and blind people. This is one of the sites we researched of the museums. As you can see on the pictures, they are hard to read even for a normal person, but for a person with visual impairment, if it sees but not fully, it will be hard to understand the text because it's not on a good contrasted background. This is one of the criteria actually to evaluate the sites. Besides the those here counted, which are WCAG, level AA, and manual testing has been done with a screen reader from a real blind person of these sites, and most of the sites of the museums are not that accessible. Here are again some conclusions. Around 30%, 29% of the sites don't have headings, and 70% have it. Semantic headings are available in only 70%, but their presence doesn't always form a logical structure which is easier from a blind person to understand. Big bold texts are not considered a heading unless they are encoded as such. Combined with semantic regions missing the structure and navigation is even more difficult to understand. The presence of semantic regions is noticed only in 16% of the sites, and a blind person relies on those things to understand the content of the site. Otherwise, all the images, all the text, if they cannot be accessed and understood and organized in a easy to read manner, it's hard for a blind person to navigate in the site. Blind people use screen readers, so the websites should be specifically made to be accessible for those screen readers. There is also some options to test through software, but we preferred to test through real testing with blind people, several, in order to get real results, because sometimes the software testing programs are not giving real results. For a blind person to understand the image, it should have a description, alt description, alternative text description. And we found from the research sites that only 5% use alternative text to convey the meaning of the images. This is a huge disadvantage because actually blind people cannot get what is on the image if it is not properly described. In many of the sites, where there was an alternative image text, it was same for several pictures, so not so detailed, not so well described. Some of the image elements, in some cases, the image elements is a part of an empty link where neither alternative text nor a link text is available. So those are some of the disadvantages we
Sorry,
found.
please hurry up a bit.
Yes, I'm reaching the conclusion. This is the picture of virtual tours of the museums, which are quite nice if person sees, but if person doesn't see, will not understand anything. So more should be done for those to be well described and understood by blind people. And conclusion is that most of the museums in Bulgaria are not that accessible, and they need to be more digitally accessible objects to be uploaded, physically accessible also facilities to be made, and hopefully that will improve in future. We will keep researching and giving the results to be used by museums and institutions to improve. Thank you.
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your career.
Thank you.
Dear Nick, Moht, Zarife, Hashim.
Yes, I'm here.
Okay, are
Can I-
ready to present?
Yes, can I share my screen? Okay.
Okay, you have 10 minutes, please.
Okay, hold on.
It's important.
Can you see my screen right now?
Yes.
Hold on.
You can start.
Hold on. Give me some minute. Slide Zoom. Can you see my slide right now?
Yes.
Okay. So okay, good. Is it good morning? Good morning to everyone. So my name is Nick from Malaysia. So I'm representative from the University Technical Malaysia Melaka. So we are located at Melaka, the historical city of Malaysia, similar to Kyoto and rest of the world. So I'm representative from the sixth author for this paper. So we call our paper a preliminary study on vowel recognition via CNN for disordered people in Malay language. Okay, so I will be talking about this listed items: introduction, research problem, objective, related works, dataset arrangement, experiment setting, result, and finally I will be concluding my presentation. So let me introduce our research at a glance. So basically, if you take a look at the right-hand corner of the graph, we can see that the projection of the non-communicable disease has been increased from 1990 to 2020. So it shows that the numbers of patients that's involved in disease has been increased quite large in terms of the number. So from these matters, basically we could consider that the all infected people or patient could be described as disordered people, which facing a difficulty to get back their ability after they gain or having the kind of disease. Okay, so speaking of the disability, we have several types of disability that we have in to extent of our knowledge. So we have speech, eyes, hearing, and so on. So this research focusing on the speech ability. So whereby in speech ability, we can conclude that we have the most important item will be vowel, followed by consonant, syllabus, phrase, and sentences. So that's the reason why we hope that we try to start our journey from the vowel, and later on we'll be hoping to get to the sentences in future. So in general, patients should attend the rehabilitation session is common for us in the in Malaysia. Hopefully the same as the whole world. So basically in Malaysia we have PKSO, the place that we give the services for rehab for those who are affected by the stroke disease. Okay. So far the rehab session was conducted by manually, and it demanding times and human power to conduct all the session and exercises for the patient. So plus again in Malaysia lately, as the COVID-19 happened in worldwide, so yes, people getting a pressure life and high blood pressure and stroke become one of our silent killer disease in our country. So in terms of the problem, basically we look up several problems that we have. Still, we are facing the listen and evaluate assessment happen in our rehab center called PKSO. And currently in PKSO, we still don't have the intelligence system for giving the rehab exercises or the practices to the patient. And we're hoping that one day we can have a full capability of an application by using the cell phone or tablet, or even by their own patient could do it by themselves at home. So plus during COVID-19, the rehabs activities is limited. So it makes us challenge to give the service to all the patients. So plus last but not least, the problem is we still have limited Malay language vowel sound datasets publicly available in the clouds. So for that particular problem, we set our objective. We have 3 objectives to go. So first of all, we propose a way to gain the voice information instead of image. So basically, if we look at the way that the voice recognition research, we are focusing on the wave files, whereby we have X and Y information. So we bring that particular information to be available in the image processing, which are considering as an image pixel. So that's the reason why we utilize the spectrogram image over here. So, and then obviously by this paper, we introduced a new Malay language vowel datasets, REUAO, with the mixed male and female subject, which consists 3 lengths of each vowel which signal. So later on, I'll be explaining about this. And lastly, we will show the proposed dataset images are comparable and acceptable in recognizing the vowel correctly via CNN, convolution neural network. So in the past few years, basically, we already checked and studied several articles about the rehab activities and rehab exercises happen in whole around the world. So the first 2 was conducted manually. Basically, the articulation disorder is one of the types of speech disorder. So that will be conducted still in manually, while the Van Piper et al. And others proposed the articulate drills and motors, which conducting the tongue movement, still also considering as the manual rehab. And then lastly, in recent years, we are oftenly hear about CNN has been used in classification activities, which we can easily see that the fruit classification and many more classification has been involved in this particular field. So for that, we think that we can fill up the information and our expertise to this particular CNN from the voice point of view, meaning with signal. So to do this, basically we have to create our own datasets from recording REUAO, the 5 vowels in our hand. So basically, as I mentioned before, we recorded from nine sample person, mixed gender, male and female, and we transform it to REUAO in spectrogram image. So obviously this is representing this one in terms of image. So then we create our own data set and we split it into 2. The first will be the training and later will be the validations images. So how we do it, basically, as I mentioned in the objective, we put it in 3 characteristics of wave signal, which is a short arc, a middle arc, and long arc. In a way that short will be arc, middle arc will be arc, and long will be kind of. Okay. So these are the sample from the 3%, the 3 types of arc for person number 1, 2, and 3, while the bottom one is E, U, E, O from the same person. So this is E, this is U, this is E, and while this is O. Right? Okay. So speaking of the experiment setting, basically we still classify the vowel for 5 categories or 5 classes: A, E, U, E, O. Obviously, this is still one more vowel to go, because in Malay language we have double E voice. So still we don't have that one, and we are working on that. And yes, we use the simple network that we build, just a matter of to show that the dataset is appropriate to be used, comparing to the VGG 16, 19, and ResNet. Okay, regarding to the result and discussion, based on the batches size that we choose, from 5 to 20, basically the validation of batch size 10 shows the 73.56 in percentage for the accuracy. And if you take a look on the epoch size 50 will be the first in rank, 76.59%. So, and then lastly, we take a look at the comparison between our simple proposed network design with VGG 16, 19, and ResNet 50. So in this particular experiment setting, we use batch 50 and several epochs number. So for this particular comparison result, we managed to show that our validation accuracy is 73.04, which considerable comparable to the 3 network model over here. Okay, last but not least, I will be concluding my presentation. So the paper delivered a systematic intelligent rehab activities friendly to be used for in the future. So basically, this is still the preliminary study, as I mentioned earlier in the topics, but we will have several tasks to be done for giving our best to the Per Queso Rehab Center. So we recorded a new data set, which is including 5 types of vowel, A, E, I, O, U, and trained the post-converted spectrogram input using the CNN. And this paper simple CNN architecture network successfully classified the vowel for about 73.04, as I mentioned earlier, and could later be used to recognize vowel from disordered people, or likewise we can describe as the stroke patient. So for future work, basically we are looking forward to add up our data sets to the multiple types of E, as I mentioned before, because in Malay we have E and E. So that would be one. And the other one is noise added wave signal, could also be considered in future, as it is considering important in observing the network reliability in many aspects and conditions during the experimental is being done. I think that's all for me. Thank you.
Thank you for your presentation. Dear participants, do you have any question about the paper? Okay, no question. Thank you again. I wish you success.
Thank you.
Dear Goyang Zhang is online. No. Okay. I want to end the session because the session is complete. Dear participants, have to see you at next session. Have a good day.
Thank you.
Thank you, Hocam.
Yeah.
Thank you.
Thank you for attending.
Thank you. Okay, bye.
Oh, you're most welcome.